during your analysis, you'll be required to compare different types of data, sometimes categorical and sometimes numeric. In this section, we're going to show you some basic techniques for comparing various forms of data sets. First one we're going to cover is categorical versus categorical. So I have two different categorical variables in this example I want to talk about. Our example for comparing categorical data is a group of college students that smoke or don't smoke and how much they study on a daily basis. So smoke and how much they study. Now a common way to look at these two variables is going to be through a table. Notice the table output. We got 0 no's that smoke for 0 hours, but 3 yeses that smoke that study for 1 hour. You can also look at the proportions of the above table to see what percentages of the populations are in each category. Notice that the table does sum up to 1, so we're good. All the proportions should be correctly calculated. Graphically, we can plot a bar plot of the categorical tables. So let's take a look. The first one uses the amount of studying as the x-axis, 1, 2, or 3. Notice that the y-axis is just a bunch of numbers, and bars split between the two categories, 1, 2, and 3. I added a little code in there to give us a nice axis and color labeling so we can easily tell the difference between the categories. So this is yes or no. If we want smokes to be our X category, and this just gives you a quantity of how many are each in the 2s or in the 3s different categories. Now, if you don't want the bars stacked, you can also add this parameter saying, hey, put them beside each other. I don't have colors in there, but you can get the hint of what it's to look like. Categorical versus numerical data. Here we have two different categories, generically labeled X and Y, both of which comes with an accompanying group of numeric values. Quick and easy way to look at the differences between multiple levels of numeric values is to plot them in a box plot. So let's run through this. Okay. I put the data in a data frame right here. This allows me to actually get the X and Y labels labeled. Now let's take a look at the box plots for just a second. The middle line is the median of each data set. The top and bottom are the 75th and the 25th quantiles, as discussed in the previous video. The lines extending out the box are called whiskers and give you an indication that the furthest reaches the data. Finally, we don't have any here, but sometimes you'll see little dots on the outside of the whiskers, and those are outliers. Numeric versus numeric data. Contrasting two different numeric data sets is pretty common. Let's go back to the iris data set and look at petal length and petal width. So let's just take a look. These are petal length and petal width. Notice they're both numeric types of data. So usually we use a scatter plot and variations of the scatter plot to explore these data. Notice that I put a tilde between these two data sets. What that means is I'm just doing petal length versus petal width, and they're appropriately labeled very nicely. I see the petal width is on the bottom and the petal length is on the top. What can we tell here? I can tell that as petal width increases, so does petal length, which makes sense. So these two values are correlated. It's a pretty handy graphic, and it's one you'll use quite often when you're comparing numeric data. Finally, if I want to get a set of the groups, right, I want to color the different groups. I also added a little bit of color to them. So I see that Virginica, the iris that are named Virginica, have the largest petal width and petal length, and the Setosa have the smallest width and nothing